square root of 4/3 minus the square root of 3/4, expressed in simplest form. Okay, so the first thing I'm going to do is I'm going to separate the square root into the numerator, the square root of 4, divided by the denominator. Square root of 3, square root of 4. I can totally do that with division and with multiplication. Now I'm going to pop out the perfects. So the square root of 4 is 2 minus the square root of 3, and the square root of 4 is perfect. So now I have two fractions and I have to find the least common denominator. So I'm just going to do it. I could rationalize this first and then find the common denominators, but I think I'm just going to find the common denominator. Common denominator between a rad 3 and a 2 is a 2 rad 3. Okay, nice and slow. What do I have to multiply the rad 3 by to make 2 rad 3? I have to multiply by 2. So I'm going to multiply the top by 2. 2 times 2 is 4. What do I have to multiply the 2 by to make it 2 rad 3? Rad 3. So I multiply the top by rad 3. And rad 3 times rad 3 is rad 9, which really is 3. When you add or subtract fractions, you keep the denominator, and then you subtract or add the numerator. This answer probably isn't in my multiple choices because it's not rationalized. So now I have to rationalize. So eventually I had to rationalize. I could have done it before I subtracted the fractions, but you could also do it afterwards. Now, how do you rationalize a 2 rad 3? You could multiply by a 2 rad 3 or just a rad 3. You don't have to do the 2. So I'm going to do it that way. 1 times rad 3 is rad 3. And 2 times 1 is 2. Those are the coefficients. And rad 3 times rad 3 is rad 9, which really is the number 3. And that gets multiplied by the 2 that's already out there. So I have rad 3 over 6. Of 16, a to the 6th, b to the 4th. Okay, so on the side of your paper, it wouldn't be a bad idea to put some of your cubes down. 2 cubed, you know, is 8. 3 cubed is 27. 4 cubed is 64. So that when you're breaking apart your perfect, getting perfect cubes, you can look over here. 8 goes into 16, yes? So we have 8 is perfect. 8 times 2. Now, when you're doing perfect exponents, they have to be multiples of 3. So 6 is a multiple of 3, so that's going to be perfect. B4, I'm going to break down to a multiple of 3, which is B3, B1. Did I lose anybody? Perfect cube, 2 pops out. When you take the cube root of a to the 6th, it's as if you're taking the exponent and dividing it by 3. So 6 divided by 3 is a squared. B cubed, the cube root of b cubed, it's like you're taking 3 and dividing it by 3. You get b to the 1st. And then left inside is the cube root of 2b. Who had it? Okay, if not, I want you to do it again. I want to break down your cubes. All right, you can stop. Okay, number 3. Number 3 says rational, actually it just says divide, but you can't divide. So what I'm going to do is rationalize my denominator. To rationalize my denominator, we learned yesterday that we're going to multiply by the conjugate. The conjugate is the same binomial with the opposite sign in between. Oops. And whatever I do to the bottom, I have to do exactly the same thing to the top. So now we're going to distribute. 12 times 3 is 36. 12 times negative rad 3 is negative 12 rad 3. And now on the bottom, I'm going to multiply it all out, but I know with conjugates, I only have to multiply the first and the last. But I'm going to do it all out. 3 times 3 is 9. 3 times negative rad 3 is negative 3 rad 3. 3 times rad 3, positive 3 rad 3. See how they cancel out? Always with conjugates. And then the last term, rad 3 times negative rad 3 is negative rad 9, which really is 3. So on the top, 36 minus 12 rad 3. And on the bottom, 9 subtract 3, which is really 36 minus 12 rad 3 over 6. But I'm not done yet. What do I have to do? I got to reduce it. Both 36 and negative 12 rad 3 is being divided by 6. So what do I say? Break it apart. I do say that, right? Break it apart. 36 divided by 6 and negative 12 rad 3 divided by 6. So my final answer, 36 divided by 6 is 6. Negative 12 divided by 6 is negative 2 rad 3. And that's the answer. You want to do it? You ready? 1 over rad 3 plus 1 over rad 2. All right, I guess the first thing I'll do is rationalize them. That's what I'll do first. So let me take 1 over rad 3 and rationalize it. It'll be easier to add that way. How do I rationalize rad 3? What do I multiply by? Rad 3. If I multiply rad 3 on the bottom, I have to multiply by rad 3 on the top. 1 times rad 3 is rad 3. And rad 3 times rad 3 is rad 9, which is 3. Now let's do 1 over rad 2. Let's rationalize it. Multiply by rad 2 over rad 2. 1 times rad 2 is rad 2. And rad 2 times rad 2 is rad 4, which is really 2. Now, I think it may be easier to add the two fractions together. Rad 3 over 3, that's what I had when I rationalized the first one, and rad 2 over 2. Because the denominators are real, and they're rational. So what should I make the common denominator? I'll make it 6. 3 times 2 is 6. So 2 times rad 3 is 2 rad 3. 2 times 3 is 6. So rad 2 times 3 is 3 rad 2. Did I lose anybody? Everyone's good? So the denominator stays 6, and the numerator, 2 rad 3 plus 3 rad 2. Can I add those together? No, because they're unlike rads. All right, number 5. Which expression is equivalent to this expression? Oh, another conjugate problem. I have to rationalize the denominator. Why can't I just divide this? 2 plus rad 3 divided by 2 minus rad 3. Are those opposites? They look like opposites. What's not opposite? The 2's, right. The 2's aren't opposites. So then it's not a completely opposite binomial. So I'm going to have to multiply by the conjugate. The conjugate of the denominator, 2 plus rad 3. And if I multiply the bottom by 2 plus rad 3, I have to also do it to the top. All right, the top has to be FOILed. Ready, set, go. 2 times 2 is 4. 2 times rad 3 is 2 rad 3. 2 times rad 3 again, 2 rad 3. And rad 3 times rad 3 is rad 9, which is really 3. I'm going to clean that up in a second. On the bottom, conjugates are faster because I only have to multiply the first and the last. 2 times 2 is 4. 2 times positive rad 3 and 2 times negative rad 3 cancel out. And then I have negative rad 3 times positive rad 3 is negative rad 9, which is really negative 3. So, clean it all up. The top, 4 plus 3 makes 7. 2 rad 3 plus 2 rad 3 is 4 rad 3. And on the bottom, I have a 4 minus a 3, which is a 1. Did I do it right? Find the solution of the square root of 2x minus 3 subtract 3 equals 6. Now, of course, a multiple choice question, you could just try all the x's. But let me show you how to solve this. It's a square root equation. The first thing we're going to do is isolate our square root. So get rid of the subtract 3 by adding 3 to both sides. That leaves me with the square root of 2x minus 3 equals 9. Now I have to get rid of the square root. So to get rid of a square root, I square both sides. I squared a square root, and it goes away. So I'm left with the radicand, 2x minus 3. And 9 squared is 81. And then you just solve the linear equation. You add 3 to both sides. 84, 2x equals 84, and then divide by 2. And you get 42. Now you check it. The square root of 2 times 42, subtract 3 has to equal 6. Does it work? I don't know. 84 minus 3, subtract 3 equals 6. The square root of 81 minus 3 equals 6. 9 minus 3 is 6. Woohoo! Who had it? Solve for x. This is a radical equation, so I'm going to square both sides. If it's isolated, you just go right to squaring both sides to get rid of the square root. When you square a square root, you're left with x plus 6 and x squared. Now it's a quadratic. We know when it's a quadratic, we have to move everything to one side. That's putting everything into standard form. So I subtracted an x and I subtracted a 6. And now, once I have the quadratic in standard form, I MAM, GCF, DOPS, and then T time. What kind of factoring is that? MAM. X plus, X minus, 3 and 2. And then we set each factor equal to 0. I'm trying to rush. And I have a negative 2 and a positive 3. And because of Fardo, this is a radical, I have to check. So let's see what works and if something doesn't work. Square root of x plus 6 equals x. If I put a negative 2 in, will it work? No, because the square root of 4 is not negative 2. Remember, I didn't initiate that square root, so we only take the primary root, the positive root. So this is a reject. The 3, though, is going to work. Square root of 9 is 3. Cha-ching! So the final answer is 3. Of 3x plus 2 is less than 1. Inequality. Draw a number line. Absolute value. Isolate it. C double. I see 3x plus 2. 3x plus 2. Set it equal to the other side, 1, and the negated other side, negative 1. And it's not really an equal problem, but we're going to pretend it is, just to find the two critical values. So I subtract 2. I get negative 1, divide by 3, and I have negative a third. That's going on my number line. Subtract 2. I get negative 3. Divide by 3. I get negative 1. That's going on my number line. Negative 1's to the left of negative 1/3. Now I have to test. I have to see if 0 works. I guess I'll test 0, but 0 is going to be over here somewhere. If 0 works, I'm going to shade out. If 0 doesn't work, I'm going to shade in. So did 0 work? Did anyone test 0? 3 times 0 plus 2 is less than 1. That's the absolute value of 2 is less than 1. The absolute value of 2 is 2. 2 is not less than 1. So 0 does not work, so I shade in between. The numbers that work are between -1 and -1/3. How do you write that? How do you state it? Well, you could say -1 is less than x is less than -1/3. Or you could do soft bracket -1 to soft bracket -1/3. That's called interval notation. That's called inequality notation. Or set notation. Number 9 says it expresses a single fraction. Fraction plus fraction. I have to add 2 fractions. This is simply telling me that if I'm working with these 2 fractions, x could not be 0, because I would have an undefined fraction, and x could not be -1, because that would give me an undefined fraction. But when you're adding these 2 fractions, it's kind of irrelevant. We're not going to really use this information. It's just telling me that. So now I'm going to get common denominators. What's the common denominator between x plus 1 and x? X plus 1 and x. Right? Common denominator? So what do I multiply x plus 1 by to get x plus 1 times x? I'm going to multiply by x. And I'm going to multiply the top by x. What am I going to multiply x by to make x times x plus 1? X plus 1. Which will leave me x plus 1. This wound up being a pretty easy problem. In the denominator, I have this. I can distribute that if I want. But I'm not going to right now. And on the top, I'm just adding 1x, and 1x is 2x plus 1. And that's your answer. I think in the multiple choice, they distributed the bottom, if you check it. Oh, I forgot to make a mistake. Yeah. I'm just so good. I never, you know. Problem! Cube root equation. All right, same thing with a radical equation. I have to isolate. So the first thing I'm going to do is, actually, I could add this whole term onto the other side if I wanted. But I'm going to subtract the 1. And that's going to leave me a negative cube root of x plus 7 equals 3. I'm not isolated yet, though. How do I get rid of this little -1? I got to divide by -1. It's like the coefficient in front was a negative. So that leaves me the cube root of x plus 7 equals -3. Now, how do I get rid of a cube root? I got a cube. So we haven't done that in a while, right? We've been square rooting both sides, or squaring both sides, but not cubing. So now I'm left with the radicand, x plus 7. And what's -3 cubed? Well, that would be a -27. And then I'm going to subtract 7 on both sides, and I'll get a -34. This must be checked. Well, actually, well, never mind. Check it anyway, but it'll work. Okay, last one. You ready? Yeah. Solve for x. The square root of 3x plus 1 plus 1 equals x. All right, we didn't practice these enough, so I really want you to go over this one again if you got it wrong. The first thing you must do is isolate your radical. So I'm going to subtract 1 on both sides. Has to be done first. The square root of 3x plus 1 equals x minus 1. I can't put those together. So now I'm going to get rid of the radical. How do I get rid of a square root? Square both sides. When you square a square root, it goes away, and you're just left with the radicand. But on this side, it's a FOIL alert. It's x minus 1 times x minus 1. All right, so let's FOIL this out. X squared, -1x and -1x is -2x. I did that quick. And then -1 times -1 is +1. Just double check me. I'm quick at foiling. Are you quick at foiling? X squared, -1x, -1x, +1. You can go back and check that. Now I have to pull everything onto one side in standard form. So I'm going to subtract the 3x and subtract the 1, leaving me 0 on the left, x squared minus 5x on the right. The 1's canceled. Now, that is not a MAM-T time. What is that? GCF T time. Very good. So I'm going to GCF. Take an x out, leaving me an x minus 5. When you T time, you're still going to T time between the two factors. The x is going to be equal to 0, or the x minus 5 is going to be equal to 0. This is one solution, and the other solution will be a 5. Will they both work? I don't know. We got to go back to the original. The original problem looked like this. Now I got to check 0. So I'm plugging a 0 in for the x. 3 times 0 plus 1 plus 1 equals 0. 0. The square root. Does it work, 0? Involved in a recycling. 3x plus 400. X is the number of months. And we want to find the number of people, that's this, in 3 months. So we're just plugging a 3 in for part A. We want to find y. Y equals 90. 3 times 3. I'm putting a 3 in for x. So all I have to do is just calculate that. I have the answer. So I have the square root of 9, which is 3. 90 times 3, 270, plus 400, 670. You can just type that whole thing into the calculator, little calculator for you. All right, part B, I'm assuming I'm going to now have to solve for the x. They say the y is 940, and they want to know how many months it's going to take. Okay, so here is our radical equation. The first thing I have to do is isolate your radical. I subtract 400 into both sides. Did I lose anybody yet? Anyone hit a wall? Now what? Divide by 90. 6. Now get rid of your square root. Square both sides. So I'm up to 36 equals 3x. And then divide by 3. Did anyone get 12? Yes? Good. I want to make everything into fractions first. Then I'm going to circle all my little denominators. Maybe I'll even change this to adding the opposite, just so I remember. I got to multiply by the least common denominator. The denominator that's going to wipe out a 1, an x, a 1, and a 1. Well, that's easy. The least common denominator is just going to be an x. I'm going to put an x there, an x there, an x there, an x there, and an x there. What I'm really doing is multiplying the numerator by x and distributing it, and the denominator by x, and I'm distributing it. So that's why it's legal. I'm really multiplying by x over x, which is the number 1. So what am I left with? Well, x times 1 is x. This x and this x cancel out. X divided by x is 1. That leaves me a negative 1. And then over here I have x times x is x squared. I have a negative 2x. And I have those x's cancel, and I'm left with a positive 1. I don't like this double sign. I'm just going to write minus 1. So I have x minus 1 over, and I'm pretty sure I can factor this. X multiplies to 1 and adds to negative 2. Negative 1 and negative 1. And then I see an x minus 1 canceling an x minus 1, leaving me, what do I have on the top? A 1. Remember on the test last chapter, some of you forgot to put that 1 on the top. Number of dogs. 4, rad, 2m plus 50. M is months, D is dogs. Just make sure you read it carefully on the test. Make sure you know what your variables mean. And it asks how many months will it take for 74 dogs? So 74, solving for m. Say to yourself, radical equation. Isolate your radical. What do I do first? I'll subtract the 50. Stop me if you get lost. So far so good? Get rid of the 4. Divide by 4. 6. Oh no. And now get rid of the radical. Square both sides. When you square a square root, you're left with 2m equals 36. 3 rad 12 minus the square root of 108, all divided by rad 3. I know that when I have a binomial divided by a monomial, I could do something called break it apart. That's what I call it. I'm going to break each term apart and divide by rad 3. So it's going to be 3 square root of 12 divided by square root of 3 minus the square root of 108 divided by the square root of 3. Remember, you're going to be dividing coefficients and radicands. So 3 divided by 1 is 3. Rad 12 divided by rad 3 is rad 4. Did I do that right? Minus, and then rad 108 divided by 3 is rad 36. Did I do that right? Hey, guess what? The square root of 4 is perfect. The square root of 4 is 2. It gets multiplied by the outside coefficient, and you're left with 6. The square root of 36 is perfect. The square root of 36 is 6. And the final answer is 0. Who had it? Number 15 is a hard one. Square root of 45 plus 3. All right, there's a lot of different ways to do this. What I did was I started to simplify things. I started to break things apart. I looked at the square root of 45 and I said, all right, 9 times 5. And the square root of 9 is perfect, is 3. And then I broke this apart because it's a quotient. So I did the square root of 1 over the square root of 5. And guys, what is the square root of 1? 1. So 3 square root of 5 plus, this is just the number 1. So 3 times 1 is 3, square root of 5. And then I looked at this and I said, all right, you know what I'm going to do? I'm going to get the common denominators. Because I have to add these two numbers. Or you could rationalize this first and then get the common denominators. That might even be easier. I don't know. But the way I did it was I got common denominator. So I'm going to make the common denominator rad 5. And if I'm making the 1 a rad 5, I have to multiply by rad 5 on the bottom. So I multiply rad 5 on the top. And that gives me 3 times, rad 5 is rad 25, which is really 5. And the 5 gets multiplied by the 3. So that will give me 15. This, of course, stays the same as a 3. I add and I get 18 rad 5, but it's not rationalized. So I have to rationalize. How do I rationalize? Multiply by rad 5. And I have 18 times rad 5 over rad 25, which is really 5. And there's your answer. That was hard. On our last quiz, we all know that this is an integer in the domain. We want the smallest integer in the domain. So let's do A. I want to find the domain of the square root of 2x minus 7. I take the radicand and I set it greater than or equal to 0. Because that's all I could put under a radical, an even index radical. So 2x minus 7 is greater than or equal to 7. 2x minus 7 is greater than or equal to 0. Add 7 to both sides. Divide by 2. And I get 3.5. What's the smallest integer greater than or equal to 3.5? 4. Boom. 3.5 is a decimal. It's not an integer. So if the x's are greater than or equal to 3.5, the smallest integer, there's a lot of integers greater, but the smallest integer in that interval is 4. Does that make sense? Say yes.
Yes.
And then part B is the square root of 6 minus 3x. I take the radican again, set it greater than or equal to 0, and solve. So 6 minus 3x is greater than or equal to 0. Watch this one carefully. Subtract the 6. Negative 3x is greater than or equal to negative 6. Now I have to divide by a negative 3. And x's are less than or equal to 2. What's the smallest integer? I don't know the smallest integer. That's the largest integer. The largest integer is 2. The smallest integer, we don't know. Negative infinity. Express the product. 3 rad 20 is being multiplied. 2 rad 5 minus 7. Okay, so we remember when you multiply coefficients and you multiply radicals. So when I multiply, I'm going to multiply 3 rad 20 times 2 rad 5. 3 times 2 is 5. I mean 6. And rad 20 times rad 5 is rad 100. 20 times 5 is 100. Minus 3 rad 20 times negative 7 is negative 21 rad 20. And now you just have to simplify this. You know that's a perfect square. So that's really 10 gets multiplied by the 6 on the outside. And how can I break up 20? 20's good job. 4 and 5. And the square root of 4, go nice and slow tomorrow. The square root of 4 is 4. 2. That's right. So you have 21 times 2 is 42 rad 5. And that's the answer. This is fun. Directions say rationalize the denominator. So when you rationalize a binomial, remember, you're going to multiply by the conjugate. The conjugate is the same binomial with a different sign in between. When you multiply conjugates, what's going to happen is you're going to multiply the first terms. You're going to multiply the outer terms. You're foiling. You're going to multiply the inner terms. And you're going to multiply the last terms. Watch the last term. Negative rad 49, which is really negative 7. Notice when you multiply conjugates, the inner and the outer term cancel out. Always. Always. They will always cancel out if they're conjugates. So, I'm left with on the bottom 25 minus 7. On the top, though, when I FOIL it all out, it's going to be 5 times 5 is 25, a 5 rad 7, another 5 rad 7, and a 7. So on the top, I'm going to have my 32 plus 10 rad 7. And what am I going to have on the bottom? 18. Now, I don't know if this was multiple choice or not, but you may not see that answer if it's multiple choice because, remember, this is division. 32 is being divided by 18, and 10 rad 7 is being divided by 18. You can simplify this. Did you all notice it? Albert's saying yes. 32 divided by 18 can be simplified, and 10 rad 7 divided by 18 can be simplified. And if you don't know how to simplify them or you're not good at simplifying them, you can put them in your calculator. 32 divided by 18 and then math bracket. 32 divided by 18 will give you a decimal, you'll math bracket, and it'll give you the fraction reduced. What is 32 over 18 reduced? 16 ninths. That's right. And then 10 over 18 reduced would be 5 ninths. Who had it? Good job. It says divide and express in simplest radical form. The square root of 18x to the 5th divided by 3 square root of x. All right, this one was a little tricky. I think the way I would have done this one is, because there's really a coefficient here in 1. I think maybe I just would have divided the radicants. Did anyone do that first? Divided the radicants? Or just cleaned it all up? You just left it like that and started to simplify it? Okay, I'm going to do it that way then. All right, so I have 18. So 9 times 2 is 18. I have to get a multiple of 2 if it's a square root. And I'm going to use the biggest one I can think of, would be x4, x1. And then I'm dividing it by a 3 and a square root of x. So let me pop out the perfect ones. The square root of 9 is 3. The square root of x to the 4th is x squared. And then left inside, I have a 2x. I have a 3 and a square root of x. Now, I have coefficients. I can divide them. 3 divided by 3 is 1. So I'm left with x squared on the outside. The inside, the radicants can be divided. What's 2x divided by x? 2x divided by x. That's what I'm doing in my head. The x's cancel, right? So I'm just left with 2. I guess that's a good way of doing it. Questions? Yes? Okay, here we go. Number 10. X over x minus 4, subtract 1 over x plus 3 equals 28. X squared minus x minus 12. The first thing I think I'll do is this, add the opposite, just so I remember that that 1 is negative. Then I think I'll do is I'll factor this denominator so that it looks like the other denominators. So I'm going to factor this and write x plus 3, x minus 4. And then I'm going to get everything to have the same denominator. So I'll rewrite this fraction with x minus 4 and x plus 3 in the denominator. X plus 3 and x minus 4. And then this is x plus 3 and x minus 4. This will stay 28. This I will have to multiply by x minus 4, so I multiply the top by x minus 4. Leaving me negative x plus 4. Check your answer just to make sure that you had a positive 4 there. And here I have to multiply by x plus 3. So I multiply the top by x plus 3. And I should have an x squared plus a 3x. Did I lose anybody? Everyone's good. The whole denominator can be just disregarded. Because I'm not adding these fractions. These fractions were already added up. What I'm trying to do is solve for x. So I can disregard the whole denominator and just look at the numerators. X squared plus 3x minus x plus 4 is supposed to equal 28. And that's how I'm going to solve for x. I combine like terms. The 3x and the minus x become 2x. I bring the 28 onto the other side. I clean this all up. And I'm left with x squared plus 2x minus 24 equals 0. Now what? What do I do now? I got a mam and tea time. So I have an x plus 6 and x minus 4. And then I'm going to set each factor equal to 0 and solve. Notice I'm going to have two answers because it was a quadratic. One answer will be 4 and one answer will be negative 6. But we remember that we always have to check with fractions. It's part of Fardo. Oh, which one? Can I put a -6 in these denominators? Yes. Can I put a 4?
No.
No. There's my reject. So the only answer is -6.